Happy New Year to everyone. This is the first video of the new year I'm recording. Hope so I'll be able to record a lot many videos for as soon as I progress in DSA. So the first program I'm taking from LeetCode is word ladder. So what this problem statement states. A transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words from begin word to S1 to S2 to SK such that. So to see that, we have one example is begin word is given as hit, end word is cog, and word list is given as hot, dot, dog, lot, log, cog. So the transformation is happening from hit to cog. And every adjacent pair of the words differ by single letter. So basically, if you see between the difference between the hit and hot is just a one character difference. That is, in hit there is I, in hot there is O. Similarly, if we see the difference between the hot and dot, there is only one letter difference, that is H and D. Similarly, for dot and dog, there is one letter word difference, that is T and G. So what it is saying, the first point is saying that every adjacent pair of the words differ by the single letter, and every SI for 1 to K in the word list, for every word in the word list, note that begin word does not need to be in the word list. So definitely, in case the begin word is not there, we need to first add that into the list and then start to see the transformation. And sk is equal to end word, that is like last word. Given the two words, begin word and the end word, and the dictionary word list, return the number of the words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. So in second example, if you see, the begin word is given as a hit and end word is given as cog, and word list dictionary is given as hot, dot, dog, lot, log. So if we see from hit to cog, the end word itself does not present into the word list. So output is 0 because the cog is not in the word list. So to understand like what kind of problem is this, first of all, for each word, there is an adjacent pair of words differ by single letter. So if we just think about the first example given itself, and if we try to find out like what are the adjacent word list for each and every word. Suppose just example for hot. For first of all, I need to, as in the given list, the begin word is not there, so I need to enter that into the list. So first is hit, and if I want to see the transformation from, so there should be just one letter difference. So if I just traverse from word like dictionary, so there will be hot because I and O, then I don't have anything, right? Now I just take the second word. So let me write all the words first, so that will go sequentially. Dot, dog, lot, and log, and cog. So for hot, if I see what can be adjacent word in the adjacency list, that could be just one character difference. So for hot, if I traverse through again the whole list, so first of all, let's make this list dictionary list. Begin word is not there, so I'm just entering that begin word into the list, and then we'll see. So first I have checked for the hit, so I have traversed through the whole dictionary and I found hot. For hot, similarly hit will be there, then again one word difference, h to d dot, and then again h lot lot. That's it, right? We don't have any other word. For dot, similarly, if I start from the starting, I have hot, then I have dog dog, then I have lot. That's it. And if I see for further for dog, I have from starting again, I will traverse like hit, hot, no, dot is nothing, no, dog, no, lot, no. For dog, dot dot will be there, T and G difference, one letter difference. Then we have log, and then we have cog. Similarly for the lot, we have hot, then dot, then log. That's it. We have got everything. For log, we have difference, one word difference. So dog, then lot. That's it. And for cog also we will have dog and then log. So if we find out one word, one letter difference for each and every word in the dictionary, then we are finding out what is the adjacency list of this. So by seeing this one sentence and how we can how can we make the graph, so it gives like this question is related to a graph. So basically we can represent the graph in the form of adjacency list. Represent the graph in the form of adjacency list. And then now we need to traverse. We can like for each and every word we got the adjacency list, means either we can go through the DFS or the BFS. We can go through the BFS, do BFS, and definitely we use the queue as a data structure to store the data. And we need to find out, while traversing through the each and every word in the dictionary, we have to compare that particular word with each and every other word of the dictionary to see whether there is, consider hit is my first node and hot is the second node. From hot I have dot and lot. So if I just try to draw that kind of graph, hit, then I have hot, and then I have dot, and then I have lot. Then from dot I have dog, and then from dog I have log. From the dot itself I am having one connection is going to the hot, another connection is going to the lot, and then it is going to the dog. Now for dog I have connection between dog to dot, then dog to log and cog. So maybe in fourth level it could be like dog is here, and then I am having log and then cog. So from hit to hot, hot has connection between hit dot lot, hit dot and lot, because they are in the adjacency list of this. For the dot, hot dog and lot, hot dog and lot are in the adjacency list. Then dog, for dog, if I make one edge like this, dot, and then I have log and cog, so 3. So for the dog, these are the 3 in the adjacency list. For the lot, if I see hot, then dot, and then log. For lot, hot, dog, and log. So in fourth level I cannot keep the log in the final level, probably, as dot has the connection with the dog also, and lot has connection with log. So now let's see, and cog is in the final, so I will just keep it in middle. So for log I have adjacency list of dog and lot, so dog and lot. And for cog I have dog and log. So this will be this is how my graph will look like. This will be my first node, then this will be my second node, this will be my third node, fourth node, fifth node, sixth node. So these will be in the same level, these will be in the same level. So if I see from hit, if I want to reach up to the end word, I am how many levels I'm traversing. If this is first level, this is second level, this is third level, this is fourth level, and this is fifth level. So after 5 level traversing through the 5 levels, finally I am reaching at my end goal, that is COP. So basically I have drawn the graph by with the help of the adjacency list which I have prepared. So let's think, like, for how can we, first of all let me just comment this. So this is how the graph will look. And now let's move to the solution. So as I was saying, like, first of all, what we need to do, we need to prepare the graph. So for preparing the graph in the form of the adjacency list, we need to have a, here you can see for each and every word we are getting which are the connected words by with the help of one character difference. So I am having key and value as the list of the string. So if I consider like how my graph, we need to prepare the graph. So for that, as we prepared the adjacency list looks like we have key and value as list of the string. So similarly, we'll start writing, we are having map of string, comma, list of string, which is, we'll call it as a word graph because we are preparing graph representation in the form of the adjacency list with the help of the map, key and value pairs. So new hash map, and we have to push, we have to traverse through the each and every word, and with that word, with the current word in place, we have to check all the remaining words in the word dictionary whether is there any difference of one character, then that character, that word will be in the adjacency list of the current word. So for that, what we are going to do, we are going to push that into the word graph. So for that, what we'll do, for we have the word list given, int I is equal to index 0 to index. Okay, before starting this, directly traversing through this, what we are going to do, first we will add the starting word. So in the starting one word in the given word list, because in second statement it is mentioned that the begin word does not need to be into the list. And as well as we have to take care of one edge case, if end word is not into the list, then we have to just return the 0 as output. If end word, if word list contains end word, so it should, if it is not there in the word list, then return 0. And as they have mentioned, like, begin word may or may not be there, so we will add the begin word in the word list. And now what will be the size of word list? It will have all the words considering the hit. Okay, let's traverse. For int I is equal to 0 to I is less than n, I plus plus. For int j is equal to I plus 1, j is less than n, j is less than n, j plus plus. Now what we need to check, how will be checking, like, if there is a difference of only one letter. So for that, I will write one method which will tell me whether only there is one letter difference. If that is true, word dot get I, comma, I have taken the first word and I will again traverse through the whole word list, word dot get j, and I will check each and every word with the current word whether there is only one letter difference. Then I'll push that into the adjacency list of that given word. So word graph dot put will use the compute if absent method. So what we want to add, for the current word, word dot get I will check if there is a, like, as we are starting now, so there will not be any list. So we'll create the list. It will give that map value. Otherwise, it will just add that value. So we want to add the, for that key we want to add the add word in the adjacency list. And similarly, vice versa will also happen. So I'll just copy this and I'll do for the J also. Like here I did for the hit. For hit, hot is there. So similarly for hot also I'll do this. So J dot I, and now we have just created a custom method where it will be telling us whether that there is difference of just one character between two words, and we are going to write that particular method. So this method is going to give us boolean is connected, and we are going to pass string, both the strings, as the length of the both the string will be same. And I'm just going to declare one variable, like initially the difference between the both the word is 0, suppose, and int m is equal to a dot length. For int I is equal to 0 to I is less than m, I'm traversing through the whole word, I plus plus, if a dot char at I is not equal to b dot char at I, then we are interested in such a case. Then we want to increase the difference. But while doing this, if difference is more than 1, then that there itself will just break this and return false. Otherwise, we are going to return true. So this will make sure that only the difference between the two words is just one character. Okay, so this is fine. Now we have created the graph in the form of the adjacency list. Now we want to traverse through, we have to do the BFS. For that we will need two things. One is the visited or unvisited, because you see here duplicacy is there, like for the dot hot. Then again for the in dot adjacency list we already visited the hot dog lot, and again the lot will be there. So we want visited array to be visited list to be maintained. So for that we'll be creating string comma boolean true or false, visited is equal to new hash map, and we have first node in our graph that will be our beginWord, and we want to create a queue of pair type where it will be of string comma integer new linked list. As soon as we got the first word, we'll put that into the, we'll mark it as visited. So beginWord comma true, and we'll push that into the queue dot add. In the queue we are going to add new pair, in which we are going to add the pair is kind of beginWord, and by default we are starting with 1. So I just did one mistake. I think here they should not look like this. It will be like pair. And now as we want to do the BFS, so what we did, we have pushed, like we have represented the graph in the form of the adjacency list, and you can see the graph will look like here. So we have pushed hit comma 1 as a pair, as a distance. 1 is the distance, and hit as a string. So first we push that, and now we want to start with the BFS, means we will start with the neighbors. So the neighbor of hit will be hot. So while q dot is empty, what we are going to do, we are going to take the value of it, read the value string current is equal to q dot pick. It is going to give the pair. We want a key. What is that string? And read string now int distance is equal to q dot pick dot get value. We got both key and value pair from the pair, and then we'll remove this particular element from q, and we have to traverse through the all the neighbors for string word in. So from where we will be getting all the neighbors of the given word graph dot get or default. So if we are passing that word, it will give us a list of. So we are passing the word, either it will give the list if it is present there, or it will create that. So we want to see whether that particular word is visited or not, right? If not visited, then only mark it as visited and then push it into the queue. So for, if we just take again an example of the, for the hit, there is a hot. So now we have visited the hit already, and for the hit hot, now it is not visited. If visit dot get or default, what is the key? Key is the given word, then visit dot put the given word comma true, and push it into the queue. Queue dot add new pair the given word comma distance plus 1. So here it was there, now from hot one level we are going plus 1, so we'll increase that. So here if you see, for the hit hot is there, so here for the hot hit dot lot is there, so hit already visited, so it will not go into the queue, only dot and lot will go. Now again for the dot, if we, so for dot if we see, hot dog lot is there, so hot is already visited and lot is also already visited, so only dog will go in queue. And then for dog, dot log cog is there, dot log and cog is there, so log is visited and dot is visited, so only cog will go. And for cog, nothing will go into the queue, and it will finish and it will give the final distance. So while doing this, if we find if current is equal to end word, then we'll return the particular distance, otherwise we can just return the 0. Let's run this. What happened? Word dot get I. So we have word graph, word, sorry, so this is like word list actually. We are getting word list, and then here also it will be word list dot get I, here also, and here also, and we are adding it into the word graph. So output is coming at 0. Why it happened? For each and every word, sorry, current dot equals It should be. It is never matching. Yes. So this is how we have finished this difficult problem from the LeetCode. Let's code together, grow together.